Alright, now we're going to take a look at graphs of polynomials. So first thing we need to look at and talk about would be what this thing end behavior is. So end behavior of a polynomial is what the y values are doing as we move to the left and to the right on the x-axis. So as x approaches positive infinity, so that means we're going to the right on the graph. So as we travel to the right, what is the y value doing? Is it going up towards positive infinity, or is it going down towards negative infinity? And then as x approaches negative infinity, this right here, so we're going to the left, what is y doing? Is it going to positive infinity or negative infinity? So that's what we're talking about when we're talking about end behavior. What is the end doing? So this is based on the degree of the polynomial and the leading coefficient. So I have a little chart here for you. So positive leading coefficient. So the leading coefficient tells you what the right-hand side of the graph does. So as we move to the right, what is the graph doing? Is it going up to infinity? That's positive leading coefficient. Or is it going down towards negative infinity? That's going to be a negative leading coefficient. So that is a leading coefficient's sign always determines what the right-hand side is doing. The degree of the function, if it is even, then the left does exactly what the right does. So if the right is going up, the left is going up. Okay? If it is an odd power, so 3, 5, 7, so forth, it does the opposite. The left does the opposite of what the right does. So if the right's going up to infinity, the left is going down to negative infinity. So that's what this chart tells you. So just to make it kind of more simple, let me do a little. This is what I always tell people to think about. If you have a graph and you graph a let's say y equals x. Y equals x, we know, is just a line going like this. So that's a positive leading coefficient, so the right-hand side is going up to positive infinity. It's an odd power, so the ends are going opposite directions. So one's going up, one's going down. All right? If we think about x squared, positive leading coefficient, we know what x squared looks like. X squared looks like this. Positive leading coefficient tells us the right-hand side goes up, and the square tells us it's an even power, so we're both going in the same direction. So if we were to graph the negative versions of these, let's see real quick. So I graph, no, that's bad. If we go to the negative version, so y equals negative x, we know that has slope of -1. We are going this direction. So leading coefficient tells me right-hand side goes down. Odd power tells me opposite directions. The same thing with a negative x squared. We know negative x squared, that flips upside down. Oops. So I want that to be here. Negative x squared goes here. Even power, both are in the same direction, and the right-hand side is going down because of the negative leading coefficient. So just go back to the basics. Go back to a linear function and a quadratic, something we've dealt with for a while. So going back to notes here. Let's try these out. So identifying leading coefficient, degree, and end behavior. So the degree of the function is a 3, so that's odd, right? Leading coefficient is a -4, so we're talking about negative. So I always like to start with the leading coefficient. So that being negative, that means the right side's going down. So the right side is this side. When x approaches infinity, that means we're going to the right. So what is y doing? What is f of x doing? F of x is approaching negative infinity. because of the leading coefficient being negative. And then the left-hand side, as x approaches negative infinity, that's going that direction. Degree is odd, so it tells me we're going opposite of what we're doing here. So we are going to positive infinity on the left side. And that's it. So let's try this one. Degree is 6. That's even. Leading coefficient is 1, positive 1. So positive 1 tells me the right-hand side is going positive infinity. And then even tells us it's the left-hand side is the same as the right-hand side. All right, degree of 5, leading coefficient of 2, positive 2, right-hand side goes up, and then the left-hand side goes down because we have an odd power, odd degree. So it's just about remembering these. It's nothing too crazy hard. We just have to remember it and know what we're doing first. Like I said, it's easiest probably to go with the leading coefficient first and then deal with the degree. So right side, then left side. All right, this is another way to look at it. We're looking at a graph instead of a function, a polynomial. So looking at a graph, we need to determine what's happening. So right-hand side of the graph, we're looking at the right-hand side. This tells us that the leading coefficient is a positive number. And the left, it goes down, which is opposite. So that's odd. Opposite is odd. Right-hand side goes down. That's a negative leading coefficient. And they're both going in the same direction, which is even. Okay, right is down. That's negative. Opposite direction, odd. Right is up. So we go positive leading coefficient and even power, going in the same direction. Okay, so you might want to write over here like leading coefficient and then degree. I forgot to add that in there. So that line is degree and then that line is leading coefficient. Okay? So now let's go back to the number of real zeros. So let's count those. So we know that there's 1 here because it crosses 1, 1, 1, and 1. So it's crossing at all of these. So 1, 2, 3, 4, 5. So 5 real zeros. 1, 2, 3, 4. They're all crossing. This one has 1. Crossing once. This one has 1, 2, 3, 4. All crossing. So remember, if they were bouncing, we'd count that as 2. All right. All right. Another way to look at what we need to do for end behavior. So we're given end behavior this time, and then we need to write a polynomial that fits the description. So this is kind of open-ended here. So what we're going to do is we're going to have x in all of these. So x to the what power and then what leading coefficient. So starting with the right-hand side. So as x goes to positive infinity, we're going to negative infinity. So we're going down. So I know it's a leading coefficient, a negative leading coefficient. So I'm just going to put -1 out there. You can put any negative number out front. And then the power, let's look at the end behaviors. So they're going in the same direction, so that means we have an even power. So any even power would work. And we're done. Next one would be, we're going towards positive infinity when we go to the right. So that's a leading coefficient, a positive leading coefficient. Opposite directions tell us it's an odd power, so I'm just going to write an odd number up there. That's it. As we go to the right, we're going positive, so positive number, leading coefficient, and same direction. So let's go 10th power is an even number, so any even number works. So that's how you do that. All right. So next thing here. Sketch a graph using graphing calculator, making sure you are plotting the zeros of the graph, then determine the multiplicity of each zero. Lastly, describe end behavior of the graph. All right. So actually, I'm going to go ahead and graph this out with you so we can see. Let's see what we got here. We got negative x cubed plus 3x squared. All right. So here's our zeros. We have a 0 at 0. And we have 1 at 3. So the 1 at 3 we're crossing through. So that's going to be an odd power, or an odd, not power, odd multiplicity. So let's just call that 1. And then we have an even multiplicity here because we're bouncing. So there are 2 of those. Okay, you can go ahead and sketch the graph once you graph it. I'm not going to do that. So that's what we're looking at. So now we talk about end behavior. I didn't mean to do that. End behavior. So as we go to the right, what's happening? As x travels to positive infinity, we are going down. So that's going to be towards negative infinity. And then as we go to the left, as x approaches negative infinity, we're going up to positive infinity. So that's all we have to do for those problems. All right, let's take a look at the next graph here. Oops. No. I'm going to get my x to the 4th. There we go. All right, plus 15x squared. All right, this is all messed up. Going on here. All right, there we go. So there's our graph. So if we come in here, we have 1 at negative 3. We have a 0 at 1, or negative 1, sorry, and at 0. So at negative 3 we're bouncing, so that is multiplicity of 2. At negative 1 we are passing through, so that is multiplicity of 1. And then at 0 we also are passing through, so multiplicity of 1. So look at end behavior. As we go to the right we are going positive, and as we go to the left we are going positive. So we are going positive for both. Okay, we could do, obviously, looking at the equation, we could tell what the end behavior was too. It's just a different way of doing it. All right. So use all the information below to graph a polynomial function. So write a polynomial, then write polynomial in factored form that represents a graph. So 2 parts here, and then we'll wrap these notes up. All right, so leading coefficient that is positive, so that tells us the right-hand side goes up. And we'll come back to that, actually, because what I like to do first is plot the zeros. So the real zeros we have at positive 3. So positive 3 is 1. At negative 3. At 0. And at 4. Okay, so we have the zeros plotted. Positive leading coefficient, like I said, that tells us that the right side end behavior is going up. So I just put a little part of an arrow there until we get situated. Degree is 5, so that tells me the left-hand side goes down because it's opposite. It's odd. Okay? So now here's where we need to think a little bit. We have a 5th degree polynomial. So there should be 5 zeros. But we only have 4 shown. So what we need to do is there's either a complex zero somewhere, or we have multiplicity of 2 on one of these. So it can't be a complex zero because complex zeros come in pairs. So there's only one missing, so we know there's a multiplicity of 2 somewhere. So let's think about this. If we go through here, we come back down, we go through here, up, and then down and bounce, that would work. So we have, this is our function. We go here to here. So right now we're at 3 zeros because we're passing through 3 of them. So now I'm hitting this one and bouncing back up because we can count that as 2 of those. So there should be a total of 5 because of our degree 5. All right, and you could really choose any one of those zeros that would work that way. Okay, just make sure it bounce off correctly. Okay. So now what we're doing is we're writing out factored form. So we had one of them at -3. We had one of them at 0, so that's going to be this x here. And then one at +3, so x minus 3. And then 2 of them at 4, so x minus 4. We can write it twice, or we can just put the power of 2 on there. It says multiplicity of 2. All right, let's go through this next one. A little bit faster this time. So -4, -1, 3. Our leading coefficient is negative, so I know I am down here. We're going negative. Degree is 4, so we are in the same direction. So 3 real zeros shown. It's a degree of 4, so we're doubling up on one of these. We have to bounce off. Okay. So we can go up through, down, and bounce off the last one. Like I said, you could bounce off any one that makes sense, that allows you to come back. Okay. All right. So now we need to write this out. So we know we had one at -4. X plus 4, we had one at -1, so x plus 1. And we have 2 of them at +3, so x minus 3 squared. Okay. Now last one. So we have 4 real zeros, so -5. I think that's 1, 2, 4, 5. Yep. -2, 1, 2, 4. So negative leading coefficient going down. 7th degree, so we are odd, so opposite. So this one's going up. Okay, so 7th degree means we should have 7 total, and then we have 4 real zeros shown, so we need to double up on a couple of these. Actually 3 of them, or one of them and have a complex zero, 2 complex zeros. So we could go through and we could, let's do this. So we gotta bounce 3 times. So if we go down, bounce, come back through, that's 3 zeros, 4 zeros. And if we bounce on the last one, we're going back up, so that's not gonna work. So that's what I was talking about before, that making sure it makes sense. And that's why I like to do it in this order. So if we go through, bounce, go through and bounce, can't do that. So we're gonna have to have some complex zeros here. Think. 2. Well, I guess we could do some bounce. We could bounce 3 times. 1, 2, 3. And so let's count. So we have 2 here, 2 here, that's 4. Another 2, that's 6. 1 there, that would be 7. So that works. So we just have to think it out. It's a little bit of a process. And that's why, like I said, that's why I like putting the end behaviors on first. Because a lot of times when people don't, they'll just have that last one going up and they'll have end behavior that's incorrect. So let's write those out. So we had one at -5. So there was 2 of those, right? We have 2 at -2. We had 2 of them at +1. And we had 1 of them at +4. Alright, so that is how we deal with end behavior on functions and graphing the zeros. So this is kind of the big idea. This is kind of bringing it all together at the end here, especially when you tie it in with factoring polynomials. And then we can do one other thing pretty much with this unit, which we'll look at in another video in a couple days here. So let's work on the work. Ask any questions if you have it, and that's it.